session. Okay. Yeah, today we will have very small class only, little set related, all these three. Okay. So tomorrow we will see about Q and map. Okay. So you can see here array list, linked list, vector and stack, and under list interface. Okay. So this is what yesterday we discussed along with that, and collections utility methods, and also collection utility methods, iterable utility methods. So all these are discussed yesterday. Okay. So now we will see the today set interface. Okay. Set. What is the main difference? List and set. We saw that the main difference. List will allow the duplicates, as well as it will allow the insertion order. Insertion order, what where you are entering into the elements into the collection classes, the same order it will be allow you. Okay. The same order, insertion order, and duplicates it will allow. Coming to set. Okay. Coming to set, see, whatever the behavior is there, right, the same behavior it will be applicable all classes, as well as individual behavior for the individual classes will be added on. Okay. The same way set also will have the some kind of features. So set will not allow the duplicate elements, and also it will not preserve the insertion order. So whenever you are printing the elements, it will be print maybe insert, maybe same order, maybe shuffling, maybe another order, right? So it will not give the any insertion order. So it will always print a shuffle order. Okay. So we will see all these three classes. So are you clear?
Yes.
Yes.
Okay. So coming to set. So let me come to the set interface. The array list and vector list and stack. Okay. Set interface. Set interface is the collection of collection that cannot contain the duplicate elements. There are three main implemented of a set interface. Three main classes. One is the hash set, and a linked hash set, and a tree set. Okay. So these are the three classes. So hash set, the common features. So just now we discussed it. The important points about the hash set classes are: hash set stores the element by using mechanism called hashing. Okay. These hashing mechanism we will discuss in map. Okay. Why? Because internally it will implement the map implementation only. Map and hash are both are implemented in hashing technique. Okay. So hash set contains unique elements only. Hash set allows the null values, which means one time null value it will be allowed. Okay, unique value, right? Null is also one unique value, right? The second time it will not allow, which means what it will do we will see. Hash set class is not synchronized, of course. Hash set and all coming from the Java 2.0 version. So from onwards, so it is not synchronized. So hash set does not maintain the insertion order. Here elements are inserted on the basis of their hash code. Okay. So maybe every element will have a hash code. How it will be contains toString as well as hash code. By implementing hash code, it will be basis of that it will be created a hash code. Okay, we will check how the hash code will be happens. Hash set will be best approach for the search operations. Why? Because the order of searching element O of n. O of n means the big O notation when we are searching elements, right? If that your program is implemented in some optimized way, you can define your program the space complexity, time complexity. Time complexity is nothing but a O of 1. So it will be give the fast searching. Okay, because of the hashing mechanism. So the elements are stored in a hashing using hashing technique. That hashing technique will be on based on the hash code. It will be calculated internally hash code. So based on that, it will store the elements inside the hash map. Hash set. Okay. See, hash. That is the reason it is added hash. The map also hash map. Got it? So that is the reason hashing is the technique for both. Got it? Don't confuse when the question is coming. What mechanism is implemented to inside the hash map and the hash set. Okay, it is both are working in a same hashing mechanism. The initial default capacity of the hash set is 16. So normally list is the 10, right? So this is 16. The load factor always 0.75, which means 75% of the capacity whenever it is filling, right? It will automatically add the next 16 elements. So dynamically it will increase 16, 16, 16 like that. Okay. So we will see. So here you can see the example. So here hash set string. Let me copy this. Okay. Okay. So here you can see collection demo. So we added one set of classes. You can see here. So 4 elements we added. So Ravi, Vijay, Arun, and Smith. So these are the unique elements only we added. Okay. So we will see initial set of elements. So I am removing a specific element from the hash set. So we can remove and we can give the direct name, right? So after removing an object method, so you can see here. So output once we remove, right? So you will have these 3 values. That is fine. After that, second hash set 1. This is the hash set, right? Hash set 1 I'm adding set Ajay, okay, and Gaurav. So now you can see here set, this is the object, right? So first object add all, second object we can add, collection we can add. So that is what we learned of the previous classes, right? So now Ravi is removed, right? So Vijay, Arun, Smith, and Ajay and Gaurav. So 3 plus 4, 2, 5 elements will be coming here. Okay. So updated list. You can see the updated list here. Okay. Updated list you can see. So removing all elements from a hash set. Remove all set 1. So we are removing set 1. So here we are printing this value only. Here hash set. Why? Because we are adding here, right? So after that we will print. Okay. After removing all method, what we are removing here, remove all, set 1 we removed. Set 1 in the sense these 2 will be removed. Okay. All in the sense whatever the elements inside this hash set. Okay. Now we will check how this set will be coming. Okay. And we are clearing here. So let me run. Okay. Remove if we know, right? If the Vijay is contained, so automatically it will be removed. Okay. The first one you can check. Initial list of elements. Vijay, Ravi, Arun, and Smith. The 4 elements. Okay. And you can added Ravi. Okay. Remove Ravi. So after removing Ravi object, you have only Vijay, Arun, and Smith. Okay. So remove. We are adding set 2, second collection object we created. Second collection object we created, and we are adding 2 names. Okay. Now what is the Vijay, Arun, Smith, right? Again, 2 elements are added here. Okay, 2 elements are added after updating list. Okay, so now we are removing all from the second list. Second list in the sense here we are removing all here, not here. Okay, this is different. This is different. Why? Because this is the first object we added, second object add all. So these 2 will be removed, not all these elements. Why? Because remove all from this second collection only we are removing. So you can see here after removing again what we are having previously we are getting here. Okay. After that remove all. After that remove if collection is having Vijay. Of course it is having Vijay, right? So next we are having Arun and Smith. So whenever we are having Arun and Smith, right? So that is fine. So and also remove if I. Now the set dot clear. So now clear in the sense we will use remove all you need to pass the collection of, or you can use the clear method by directly taking that collection dot clear. So it will be clear. Obviously, empty set will be printed. Empty set or empty collection. Okay, empty array, right? So are you clear? Let me add here. So are you clear? All the methods here?
Yeah, the methods are clear. You mentioned that the set, the set collection doesn't have the sorted elements on the way they being added.
Exactly. See, sorted. That is what I will show you. See, if you see here, sort method is the collection interface. Okay, sort method is the collection interface. Where is the sort method here? Let me show you and check. So size, add, remove, and clear. Collections. I think that is. So root dot add collections dot sort. Okay. So let me take that second one.
Yes.
Collections dot revert, and collection dot sort. So
Mhm.
collections is also utility method in the collection interface. We can use the sort method also. Let me use the sort method also here. So yeah, you can use any of collections dot is empty and all. Sort method is also there. So many is there. Frequency method is also there. Okay.
Okay, I understand that methods there. The question that I got, maybe I didn't ask properly, but you mentioned, for example, when we are working with an array list, when you're inserting data, when you're printing, for example, the information is going to be sorted as the objects being added to the list. In this, using the set is the same, that you can have the elements, or it could change, as you say, soft shuffle. Is that right?
Collections dot sort, you can see here, collection dot sort, it is taking the list element only. Okay, list element only. So you can convert the set to list. Okay, so you can convert the set to list. Okay, so by converting set to list, you can pass that element here. So list of strings, string list equals to new array list of a collection element. Okay, collection element. So you can give this set. We will check whether we can pass the set or not. What it is asking. So resizable array implementation list interface and implement collection option will be there. And yeah, you cannot synchronize a list. Okay. So it is not taking. Whenever you are passing this, it is not taking. Size is empty. Get the set is iteration and the list iteration is contained the add the performance. Okay. So we cannot convert this. Okay. We will check how we can convert.
Okay.
Yeah, we can convert. Yeah, it is already taking. Yeah. Now you can pass this list. Okay. You can pass this. Okay. Or directly, I think we can give this also. Let me try. That is what I given, right? Yeah. This is also we can give. So you can convert the list and you can use the sort method. So collection dot sort method and reverse and all, it will take only list instead of set. Okay. So let me run. Let me run here. So set is after removing Ravi, the set one. Okay, set we are preparing, right? So if it is list, it will be you can print here after converting. And also be sorting this method. Let me run. See here after converting set to list, we are printing the list, right? Vijay, Ravi, Arun, and Smith. So it is not sorted. We are okay. We need to give this list. Yeah, now it is Arun, Ravi, Smith, and Vijay. So now it is sorted. Okay, whenever you are converting properly, so that list was sorted here, and you can print here. So this is what set to list. And whenever we are using the collection methods, right, we are aware of that. So now tell me, what is your question?
No, my question was related about the list. When you're inserting the data, when you're adding data, the list is going to be printed. Let's say we are printing it. It's going to be printed as the way as the data was being inserted. In the case of the set, is going to be the behavior is going to be the same. Is going to be printed in the same way, or is going to be shuffled? Is going to be changed the order?
It's going to be changed, right? It will not preserve the order. It will not preserve the same order. It will preserve the shuffling order. We will not get the same order always. Okay. So let me add these two also here. Let me comment out all these things. Okay. Now you can see. So we added Ravi, Vijay, Arun, Smith, and Ajay and Gaurav, right? The same order it will not give always, okay? So in such order it will not preserve. That is what we're reading, right? See, first it is giving Vijay instead of Ravi, okay? Okay. But after that Ravi, after that Arun, after that Gaurav. Gaurav we added last, but it is giving mid of the array, right? Smith and Ajay. So it will not give the any incest order, okay? That is one part. The second part is we can add null also.
Just one null value.
And we will add another null. Okay. Okay. We will check. It is giving two nulls here. Here directly you are adding a null value, actual null value. Here adding a string. So the hash code of both are different. This is the string null. This is normal null. Okay. Now you can add one more null. One more null. Okay. Now you can check. See, you are getting only two nulls only. Are you clear? Why? Because whenever you are adding the same kind of element, it will be override. So you can add one more Ravi here. One more Ravi. So you will not get a array. Why? Because it will always contain the unique elements. Unique elements. You can see here, only one Ravi is coming entire here, but two nulls are coming. Why? Because here you are adding a two nulls. Okay, not this one string. If you're adding one more string here, it will not come again. So string is different. String text is different. Directly null is different. Okay, you can see here only two nulls are coming. So even though you are adding the same kind of element again, it will override. It is also same kind of element. It will override. So be conscious on these things. Okay. So interviewer maybe ask like this also. Okay. Right. Got it?
Yeah. Thank you so much for
Yeah.
explanation. Thank you.
Yeah. Now coming to the second, linked hash set. Okay. We are going to see the linked hash set interface. It is done. Now linked hash set. So linked hash set is having little bit one or two values will be added here. Why? Because linked hash set will be the this is also double linked list, right? We will see. Java linked asset class is the hash table and the linked list implementation. So these are the two implementation. Okay, set of the set interface. It inherits the hash set class and implements the set interface. Okay. The important points about the linked list set are linked asset class are linked asset class contains the unique elements only like asset, the same behavior. Why? Because it implements set interface, right? Linked asset class provides all the optional set operations, permits the null elements also. Okay. Class provides all optional set operations, permits the null operations, like same asset behavior. Okay. Linked asset class is the non-synchronized. Linked asset class maintains the insertion order. Why it is following the order now? You can see here, it implements the list also. Hash table and linked list implementation, linked list implementation. Whenever it is coming a list implementation, automatically it will order the insertion order here. So Java linked asset insertion order. Now the requirement I will this is one question, the most asking question. So you have a collection of elements in your hand. So you want to store one collection class. So that collection class should not be allowed duplicates and it should allow the insertion order. At that time, what type of collection class should I prefer to use? The answer is linked hash set. Why? Because it will not allow the duplicates. The first one. Why? Because it is a child of hash set, right? Set. So it will not allow. And also it will implement the mechanism like linked list, which means list, which means it will have the insertion order. So that is what the tricky here. Got it? Hello?
Yes, sure.
Yes.
Okay. Okay. Keeping insertion order in a linked asset has some additional cost, both some terms extra memory and extra CPU cycles. Therefore, it is not required to maintain the insertion order. Go for the lightweight hash map or the hash set instead of going a linked asset. Okay. So whenever why? Because internally it is doing many operations by keeping insertion order as well as duplicate elements. So the specific requirement only you need to use the linked hash set. So otherwise you can go for the hash map or hash set. Previously we used it as hash set. So if you want insertion order and also not allowed the duplicates, you can go for the linked hash set. Until and unless you should not use this. So because of the it will use the main more CPU. Why? Because of these internal features. Okay. So let me take this. Okay. So here you can see. So Paul, Ram, Aaron, Leo, Bresky, right? Becky or Becky. Okay. So you added 5 names. Okay. So it will not allow the duplicates. Let me add one more Paul. Okay. One more Paul. And okay, two nulls. So it will follow the insertion order first of all. See, one Paul is added, and one null is added. Ram is added, Aaron is added, Leo is added, Becky is added. So are you clear? So it will not allow the duplicates, and it will follow the insertion order. If you want to go such kind of scenario, you need to go for a linked hash set class. Are you clear?
Yes, we.
Yes.
Okay, fine. Now coming to the tree set. So this is also one more set implemented class, and also we will see what we'll have here. The important points of the tree set class are: tree set class is the contains unique elements like linked hash set. So let me duplicate this, and I will show you that. Yeah, here tree set. So sorted set is the implemented interface. From here the tree set is implemented, which means the elements are sorted. Whenever you are using this, you no need to use the sort method from the collections class. Okay, you need to convert the list, and you need to. So if you want a sorting mechanism in one time, or in a single time, you can go for the tree set from the set. So unique elements as well as sorting mechanism. So by default, it will have the ascending order like A to Z, right? So sorting mechanism, it will be there whenever you are using a tree set. So we will see directly it is using the set interface, and linked asset from here. We will see. So the access and the retrieval time is the quite fast. Why? Because sorting mechanism, right? Sorting whenever you are using, it contains commonly unique elements like hash set only. That's fine. Why? Because from the set it is implemented. From the set it is implemented. From the set it is implemented. Okay. Coming to here, tree set access the retrieval time are quite fast. We will see how it is fast because of the sorting mechanism. Class does not allow the null elements. So this is the one more unique added advantage. And also this is not synchronized. It is maintaining the ascending order. The default mechanism of a sort method or sorting mechanism is the ascending order. So it will have the ascending order. Class contain the unique elements only like hash set. So that is fine. And the retrieval time fast. So two times I added. Okay, that's fine. The class is the main ascending order. Okay, we will see now. Now tree set. So I added Paul, Ram, Aaron, Leo, and Becky. Yes, key. So I added 2 times. Okay, that is one. And it will not allow the null elements, right? It will not allow the null elements. Let me add null. It will not allow, right? So I added. Okay. So just I'm printing. See, null pointer exception. So syntactically it is correct. Syntactically it is correct. But whenever you're running your application, the checked exceptions, the unchecked exception is coming. Okay, checked exception is syntax. The syntax is correct. So we are adding the statement. We are using the add method. We are adding the element, but the behavior of the class will not allow the null elements, so that it will give the null pointer exception dynamically, especially for the tree set. Okay, tree set. You can see null pointer exception. So you should not use this. So you can use. We will check this null also. This null also we will check. It will be string. It is not a direct null. We will check. See, we are getting. Are you clear? The null is it is a string text, not a direct null. It is not. It is having object. Okay, Null is means it is not having anything, nothing. Okay, it will be empty or it will be nothing, not empty also. Empty is having some space, right? It is nothing. But here, whenever you are giving it is not a null. N is one character, U is one character, L is one character, and L is one character. It is a kind of text. Okay, that is the reason it is taking. Got it? And whenever we are doing a sorting mechanism, so it know the content of the null is a null value, right? So that is the reason it is giving the here insertion order here. So let me add here one more zebra to make it clear. See, so if you see, it should come before Z, right? Previously we discussed, but the content of this string is a text, and also considered as a null means a text, the value which will not having any accessible or any important value. The null means we cannot consider as a text or name or anything. Just it is a simple text of a null value. So that is the reason it is added as a end of the strings. Okay, got it? But still it will be considered as a text. Why? Because it is a text of 4 characters, but no values when we are checking the content of the string. Got it?
Yes, it's clear.
Yeah. So here the tree set will always follow the ascending order. So Aaron is coming the first, A to B, A to Z is coming like that. So whenever you're adding this null, it is a text, it is allowing. Whenever you're adding direct null, it will not allow. Okay, it will give the null pointer exception at a runtime because of it is unchecked exceptions. Syntactically, it is correct. Check it when you're checking, when you're writing, it will our ID it will check. Okay, when you're writing, you can see. Check it. If you remove this one, okay, it will give the error. It will give the error. Why? Because in syntax error, this is the checked exception. This is the checked exception. Syntax error. Okay. So whenever you are giving this, it will work. If you are giving null here, that is also fine. And syntactically it is fine. But it will give the null pointer exception at runtime. Because tree set will not allow the null. Okay, one time null also it will not allow. So this null is different and this null is different. This null will be the text of a null value. This will be the direct null. Null means no object will be there. It is a null. So that we will get the null pointer exception. Okay, got it?
I got it.
Okay. So now the main when to use hash set and when to use linked hash set and when to use tree set. So this is what whenever we are learning these collections, right? So we need to know the clear picture about the collection classes, so that whenever you are writing your code, you will add this use the proper collection in your requirement of your day-to-day code. So use hash set when there is no need to keep any order. First thing, when you any no order, and the group of elements should be the unique. So these two conditions, if your requirement from your requirement, you can go for the hash set. When there is no need to keep any order in elements, but group of unique object is needed. Unique objects means unique elements. Okay, then go for hash set. That is fine. It is again one more here. When group of elements, unique elements, if you want unique, same feature, and need to insertion order, which means you need order, then go for the linked hash set. Elements also required, insertion order also required, the order also required, you can go for the linked hash set. Now tree set, when group of unique elements or objects is needed, sorting elements and required according to the same unique as well as ascending order or sorting order. Sorting order is nothing but ascending order only, default order. You can go for the tree set. So in internally it will use the comparator for the sorting order. Okay, comparator is the one of the interface. it will go for, it will use the sorting mechanism. Okay, so we will see what comparator and what comparable interfaces from the Java we will see in a map. Okay, not here. So now you can see the differences between these three. So we already know differences, right? So you can see here how they internally see considering points I added here. Okay, how they work internally, all these three. Hash set uses the hash map because hash, these two are following the hashing mechanism. Internally stores the elements. Okay, uses the hash map. Hash map will follow the hashing mechanism. Okay, hash set. Linked hash set uses the linked hash map. So internally stores the element. So we will see what is the linked hash map in a map. Tree set uses the tree map. So always entire set uses the map related implementation only with respect to the same kind of classes. Hash set will use the hash map and linked hash set will use the linked hash map and tree set will use the tree map internally. That's fine. Order of elements. Hash set, we know, right? It does not maintain any order. Linked hash set, it will maintain the insertion order. Elements are placed there, inserted. How you inserted, it's the same. Tree set orders elements according to the supplied comparator. Supplied comparator in the sense the ascending order, right? So if no comparator is supplied, elements are to be placed in the natural ascending order. Okay, natural ascending order. We will see. So we can comparator in the sense we can sorting based on the name, based on the salary, based on the age, right? The same way the names will be printed or arranged. If you are passing the comparator, it will be comparator what way of elements to be sorted. If you are mentioned like that, it will give the same kind of element. If you are not passing any comparator, it will give the natural ascending order, the default ascending order. Okay, this is what the tree set. The performance, this is also main important. You can think based on the operations individual classes, based on that performance also will give. Asset gives the better performance than the linked asset tree set. Why? Because tree set is also having internally some sorting mechanism. Linked asset also having some insertion order by arranging the all the elements. Okay, tree set and these two. So that is the reason it will not give the only asking mechanism. It will not have any internal mechanisms here. So that is the reason it will give the better performance than tree set and linked asset. Now we will come here. The performance of linked asset is between asset and tree set. Asset and tree set. The performance almost similar to the hash set, but slightly slower side, as it is also maintains the linked list internally to maintain the insertion order of the elements. Okay, so it is slightly slower. Okay, slightly slower because it is used the linked list internally. Whenever you are removing element, it will shuffle the first to the second and second to the first, like that based because of the no elements, right? So little slower. Okay, tree set gives the less performance than the hash set and linked hash set, as it is sorted elements after each insert removal operations. This is also okay, but linked hash set will have little best than tree set, but lower than hash set. It is a medium. Okay, now this is performance related, gives the less performance than these two classes. Why? Because these two having little fast compared to this one. Fine. So insertion and removal and retrieval operations. So what kind of these operations, how we can do in this here? So asset gives the performance of O of n, order of n, or O of n. Okay, insertion and removal and retrieval operations. Linked asset also give the order of O of n. Tree set will gives the log O of log n, which means this is the same. Why? Because they are following hash map and the linked hash map. Whenever you are passing linked hash map, it will give the immediate element, right? While doing. But tree set is having some insertion order. Internally, it is implemented. So slightly, it will take little fraction of second, little more time. So that is the reason it is having some factor. It is adding the performance while operations. The time complexity it is adding like this. So how they compare elements? Hash set uses the equals method and hash code methods to compare the elements and remove the possible duplicate elements. So whenever you're adding, right? So linked asset also equals method and hash code methods. So tree set uses the compare method and comparator to or compare to methods to compare the elements and removing the possible duplicates element. It does not use the equals and hash code methods, the comparison of elements, right? Internally it is having the comparator class. From that class we have two methods. Okay, two methods. Of course it is an interface. We have two methods. We will see. So whether it is a comparator or we will see here. Tree set, navigable set, and clonable and abstract set. Okay. So we will have a comparator also here. What kind of this we will see. It is an interface. Okay. It is an interface, right? We will have a compare method, object 1 and object 2, which means element 1 and element 2, and also it is having some equals method, and also reverse order also there. It is internally it is in collections class only, reverse order, and also compare to is also there method, comparator, then comparing, compare to. I'm seeing the next method. Comparator only it is having. Okay, we will check whenever we are coming the comparable and yeah, in the comparable we have a comparator too. Comparable is also yeah, here we have a compare to method. Okay, so these two methods will be there. Okay, fine. Now null elements. Asset will allow the maximum one null element. Linked asset also will allow the maximum one null element because of unique nature. Tree set will give the null pointer exception. Just now we saw that example. Okay, memory occupation. So asset requires the less memory than linked asset and tree set. Why? Because it is having the extra operations between them, right? And it is usually hash map internally stores the elements. Linked asset requires the more memory than asset also maintains the linked list along the hash map store the element. So linked list is the one of the implementation from the linked asset. So that is the reason it requires the more memory than hash map. So tree set also requires the more memory than asset, and it is also maintain the comparator to sort the elements. So these two are the little bit more memory compared to hash map. Okay, when to use? So of course we already discussed above. Use the asset if you don't want to maintain the order of elements and unique elements. Use the linked asset if you want to maintain the insertion order. Use the tree set if you want to have the according to comparator ascending order, right? So simple. So now you are clear all these three classes. Are you clear?
Yeah.
Yes, we're clear.
Yeah. This is what a collection class, collection classes subset, and tomorrow we will have. Tomorrow for me it is a Saturday. For you it is a Friday. So we will have a class. So again we will go to that queue and map also we will see. Map classes also. Map classes we have like hash map and tree map. So we will see linked hash map also there. So I will add one more diagram clearly with respect to map related hierarchy. So right like this I will add. Okay. So we will meet tomorrow. Okay.
Okay.
Yeah. Thank you. So after a few minutes, I will provide this class in YouTube channel. So I think you are having this. Let me open. You can directly open Vkakarla in Google. So you can go for the playlist. Okay, playlist. So
Okay.
2023 Spring Boot microservices. Okay, you can go for this. Okay, this one. So whenever you are seeing this, right, you will have one by one in a ascending order. So first one is the core Java part 1, second one is the core Java part 2, and then strings, then exception handling part 1 and part 2, and threads and collection part 1 added. So today I will add collection part 2 also. Okay, got it?
Yeah, I have a doubt.
Yeah.
Yeah, in the next class, we will see some the collection, but with threads. For example,
Yeah.
hash map. Okay. Okay.
Yeah, Q we will see. Q and map we will see next class. I will try to finish Q and map in one class, next class.
Okay, because I have a doubt in the hash map, but with threads. So I have
No,
problems.
threads, yeah, threads. See, threads in the sense here also we have a threads, okay. Copy of array list and a copy of linked asset we have. So that I will discuss after end of the collections, okay.
Okay.
See,
okay.
whenever we see these classes, whatever we are discussing these classes, except from vector and stack, non-synchronized. If you want to go for the synchronized manner, we will go for the some concurrent enabled collection classes. Those are classes we will discuss the end of the collections. So instead of confusing by saying all these in one place, you will confuse. So I'm coming in a sequential order. Okay.
Right. Got it.
Yeah.
Thank you.
Thank you. Thank you very much. And make sure you are going and taking all these in a right manner. Okay. You go for the playlist and open this, and whenever you're opening, it will be come in an ordered way. Okay.
Okay.
Got it?
Yeah.
Yeah.
Okay. Thank you.
Yeah. Thank you.